Alright, so here we have a basic circuit. We're going to find the input impedance. Take it from the time domain and into the S domain to come out with a transfer function. This will give us the ability to test the breakpoints and do a Bode plot. So here, basic circuit, basic impedance, product over sum for these two legs plus 1 ohm, simplified down into S plus 3/2 over S plus 1/2. Now from here we can look at it for a straight line approximation instead of doing out the long form of the Bode. We can look at and say that the frequency will break at approximately 1/2. So at 1/2, when S is less than 1/2, what will this function do? Looking at it here, you can say that the 3/2 is far greater than the 1/2. So your numerator will be 3/2. It's less than the 1/2, so the 1/2 will dominate. And looking at it like that, we can say break frequency of 3. Then converting that into decibels, say 20 log of 3, will give us a 9.5 decibel. And we'll proceed through and do it for each instance of the break frequencies. And from this, we'll be able to have points to plot and give us a general straight line approximation in terms of magnitude and frequency. Now here, in an instance where we have S and we're taking the log to get it into decibel, we'll plug in, essentially S will be, we'll look at it as omega. So we can say S, and then we'll have our decibels. Say at 0.5, it'll give us the 9.5. And then we'll go say 1.5, and it should come out of 0 decibels. And those will be our points that we plot. Now for the last piece here. When S is greater than 3/2, S will dominate in both instances, and we just get 1, which is 0 dB, meaning it'll flatline. Okay, so now that we have our log scale set up here to plot our breakpoints, looked at, we had for the initial response a break at 9.5 decibels. At 0 dB, and then, and this was this range 0.5 to 1.5 in terms of frequency. So we can look here let's say about 0.5 at around 9.5 dB is our point. And we know, because there's no S, that it's just going to be a straight line from there to there. Now our other point here of 1.5 is 0. And our last point stayed at 0. So we can now take, we've got a straight edge, remember this, we're going here. And that would be the basic of a straight line approximation. Now the actual would more than likely follow, it'd be a smooth curve. And would probably look something like that. But for what we're doing, a straight line approximation will give us all the data we need.